Good morning, everyone. Go ahead and check your homework answers and pause the video if you need more time. Our lesson today is about pyramids and cones. So we're going to start first by talking about the lateral area of a right circular cone. So the lateral area is all this area that you would paint on the outside of the cone, except for the base. So this base down here is not included. It's just the area on the outside on top. So to find the lateral area, you just have to memorize pi r L. So the L is representing the slant height. So L is your slant height. It's not the height or the altitude of the cone. Instead, it's the length of the slant right here. So start that one, have to memorize that one. Surface area of a cone is that lateral area, and then we're going to add in the base. So we have the lateral area right here, and then we add on the base, which is the circle. So the area of a circle is pi r squared, so that's why that part is included. The volume of a right circular cone is 1/3 the volume of, and this should look very familiar, a cylinder. So it's 1/3 the volume of a cylinder. Some of these are on the reference sheet that you got at the start of the unit. And you should notice that you need to remember the lateral area of a right circular cone, that's not on there, and the surface area of a cone is not on there, but the volume of the cone is on there. The lateral area of a pyramid. So a pyramid has a lot of different shapes in terms of its base, but the lateral area is just going to be when you add up the area of all the surfaces going around, but not including the base, so not including this bottom part. So the sum of the areas of all the lateral faces. So in this example right here, I have a lateral face here that's a triangle, and then I have another one in the back, and then I have one on the side, and then another one on the side. The surface area of a pyramid is take that lateral area you just found and then add the area of the base. So in this picture down here, we have our base right here that we have to find the area of. And then we have to find the area of each of these lateral faces, which are triangles, and the ones in the back as well. The volume of a pyramid is 1/3 the base area and then times the height of the actual pyramid. All right, let's put some of these to use. It says determine the exact volume of the cone. So exact volume means I'm going to leave my answers either in radicals or with pi. So volume of a cone is 1/3 pi r squared h. So I have what information? Well, this right here is the height. So I have the 11 as the height. But what I don't have the radius. That's right here. But we should notice this right triangle. So we can use the Pythagorean theorem to find our missing leg, which is the radius. So we have 11 squared plus, I don't know the radius side, that leg, and then radical 137 squared. So 121 plus b squared equals 137. I get 16, take the square root. Technically, it's plus or minus 4, but negative radius doesn't make any sense, so it's positive 4. All right, so I've got 1/3, and I'm going to have 16, and then times 11, and then I have my pi. So now I just have to multiply. And I know, obviously our calculator can handle this, but if I divided by the 1/3, I'm going to get a repeating decimal unless 11 times 16 is divisible by 3. So I know it's probably going to be out of thirds. So I have 176 thirds times pi, and that's my units are going to be cubed because it's volume. That would be my exact. Next, it wants me to find the lateral area and surface area of the cone to the nearest hundredth. So this means it doesn't want the exact, it does want me to round. So let's start with the lateral area. Pi r L. Have to memorize it. So I have the pi. Do I have my radius? Yes, that's 16. Do I have the slant height? Yes, this is the slant height. This would be the height of the cone. I don't need the height of the cone right now, but you can see how I could find it if I needed to. All right, so 16 times 24. This would be the exact answer with the pi. And then if I just multiply 384 times pi, I get 1,206.37. And I'm talking about area right now, so that's feet squared. My surface area is going to be that lateral area plus, now I'm going to include the base. So the base is the shape of a circle, so pi r squared. So once again, this is the lateral area, and then this is the base area. Well, I already have this. I'm going to write it as the exact first. And now for the base area, my radius is 16. So if the question asked for the exact surface area, I would keep everything in terms of pi, and I'd get 640 pi because I'm able to add the 384 pi to the 256 pi, and this would be the answer for the exact right here. But it wants me to round, so now I'm going to multiply 640 by pi, and I get 2010.619 something something. So that 9 is going to make 2010.62 feet squared, because I'm talking about surface area. All right, I got another one. I'm going to do the lateral area first. See if you know it. Pi r L. So pi. Do I have my radius? Yep. So I have my radius of 5. And then do I have my slant height? I do. Remember, this would be the height if I was doing volume, but for surface area and lateral area, I need that slant height, so 10. So 50 pi would be the exact. But I want to round. So now I'm going to do 50 times pi. And that's going to round to 800ths. And that's feet squared. All right, surface area. Taking that lateral area, and that's going to add on that base. And the base, once again, is the shape of a circle. So lateral area, base area. So this was 50 pi, and now I'm adding on pi r squared, so that's 5 squared. So 50 pi plus 25 pi. This would be the exact, the 75 pi. And then if I just multiply by pi, I get 235.62 feet squared. Three, I want to find the volume of the pyramid. So draw in, it's not very good. I'm trying to draw in a right angle here so that you know this is a square. I'm really struggling here with my drawing, but that's supposed to be a right angle. So the volume of a pyramid is 1/3 base area times height. So 1/3. What is my base? My base is that square. So that's going to be 12 times 12 for the area of the square. And then times my height, which is 16. So I'm going to multiply that all together. And I get 768. And this is volume. So my units are cubed. A square pyramid has a volume of 245 inches cubed. The height of the pyramid is 15 inches. What is the area of the base of the perimeter, or base of the pyramid? What are the dimensions of the base? So just to help us visualize this a little better, if I were to make a little sketch, oops, I thought I hit copy. Copy. It's telling me, oh, black this out, we don't need this. It's telling me that I have a square pyramid again. And the volume is 245 inches cubed. So that means 245 is equal to 1/3 base area times height. And it wants me to figure out the base area, knowing that the height is 15 inches. All right, so I have 245 equals 1/3 base area times the height. Well, using the commutative property, I'm able to multiply the 1/3 times the 15, which is 5. And now all I have to do is divide by the 5 in order to get the base area. So 245 divided by 5 is 49. So the area of this base would be 49 units squared. So then what are the dimensions? Well, a square is side times side, or side squared. So when I take that square root, I see the side has to be 7. So my base area is the 49 units squared, and the dimensions are 7 by 7. Five. Suppose you fill a cylindrical paper cup that has a height of 6 inches with water. If the water is then poured into a cylindrical cup with the same radius and height as the conical paper cup, to what height will the water reach in the cylindrical cup? So think about what it's asking me to do. I've got a cone as a cup, and I fill it up so that it has a height of 6 inches with water. So 6 inches filled with water. The water is then poured into a cylinder shaped cup. And the cylinder says it has the same radius as the cone. and it also has the same height. To what height will the water reach? So think about that for a moment. If you need more time to think, go ahead and pause. So it's really talking about volume, right? So if you're not seeing it right away, write down the volume of a cone. So 1/3 pi r squared h. And then, so that's the cone. And then write down the volume of a cylinder. Pi r squared h. All right, so I know that their radius is the same in both. And I'm also told that their height is the same. And they actually give me the height. The height is 6. So I can multiply the 1/3 times 6, and I have 2 pi r squared. So now if I look at the cylinder, and I know the height is 6, actually, let me take that back. I know the height of this cone, or excuse me, the cylinder is 6, but it's asking me how far up it's going to go. So I'm actually going to leave this as h because I don't know how high it's going to be filled up in yet. And now I'm going to put this in for the volume. This is my volume. So what can I divide out on both sides? Do you see that I have a pi r squared? I can divide from both sides and end up with a height of 2. So if I were to take this filled with some liquid and pour it into this, it's only going to go up to 2 inches. Hopefully that makes sense, because what do you know about the cone's volume compared to the cylinder? It's only 1/3 of it. So that's why there's that relationship. If this height is 6 full of water, it's only going to fill up to 2 inches because 6 times 1/3 is 2. So you might have saw that without all the algebra, but if you didn't, the algebra supports the answer as well. So then how many conical cups would it take to fill the cylindrical cup? You should be thinking 3, because the first cup here, the second cup, would do another 2 inches of water, and then the third cup would finish it off. Six. A cone fits inside a cylinder so that their bases are the same and their heights are the same, as shown in the diagram below. Calculate the volume that is inside the cylinder but outside the cone. Give an exact answer. So it wants this volume. Well, technically this goes right to the top. So all that on the side. So go ahead and pause if you need some time to think about this. But I simply want to do the volume of the cylinder minus the volume of the cone. And then some of you might be thinking that you already have another idea of how to approach this. We'll talk about that in a second. So we have cylinder, pi r squared h, minus the cone, 1/3 pi r squared h. So once again, we have a really strong relationship here. We know the cone's volume is 1/3 of the cylinder's volume. So the cylinder, I have a radius of 5 and a height of 12. For the cone, radius of 5, height of 12. These expressions are almost the same except for that 1/3. So we could just go ahead and compute this, but I want you to notice that if you think of this as like terms, I can actually say 2/3 of the volume of the cylinder is left. And I can compute this. If that's not working in your brain, then go back to this step right here and just go ahead and figure it out. So what do we have? We have 25 times 12. So I have 300 pi minus, and now I'm going to figure out this whole expression, which turns out to be 100 pi. So that would be 200 pi for my volume in units cubed. And then if I do my work that I was working on down here, I will get the same thing, because if I do 300 times 2/3, I get 200, and once, oh, forgot the pi, 200 pi units cubed. So nothing wrong with going this route, but this is just neat to show you that relationship once again, that the volume of the cone is only 1/3 the volume of the cylinder, so the area, the volume that's left has to be 2/3 the volume of the cylinder. I will put this video on Schoology, and your homework tonight is the day 7. Have a great day, everyone, and I'll see you tomorrow. Bye.